All right, what's up, guys? This is question number 4 from the 2017 AB exam. This is the potato question. All right, and you're told that this right here is a derivative that's given, and you're also given that h of 0 is equal to 91, and h is the internal temperature of the potato. All right. In part A, you're supposed to write the equation of a line tangent to the graph of h at t equals 0, and then use that to approximate the internal temperature of the potato at time 3. Okay, so just to point out to you, dH dt over here is in terms of h, right? Okay, fine. So to write a tangent line, you need a point and a slope. Well, h of 0 equals 91, like that's your point, right? And that's a t value, that's an h value. And then to get your slope, you got to plug in the coordinate into your derivative. Well, again, your derivative is in terms of h. So like I can't plug a 0 in because 0 is a t. So I got to plug the corresponding h in, right? So 91 is the h value, so I'm replacing h with 91. Gives me negative 16. Okay, so here's my tangent line, and I just use h's and t's instead of x's and y's because those are the variables. Okay, but that's not a big deal. And then this cleans up to h equals negative 16t plus 91. And you're supposed to use that to approximate the internal temperature at time 3. Just plug a 3 in wherever you see t. Evaluate it, 43 degrees Celsius. All right, part B. It says use the second derivative to determine whether your answer in part A is an underestimate or overestimate of the internal temperature of the potato at time 3. Okay, so we first got to find out what the second derivative is. All right, so I just rewrote the first derivative right here. And like I knew that I was going to be deriving this guy here, and I didn't really like the fact that negative 1/4 was out here to just like put him in there to make it easier to see. So here's like just the distributed version of the first derivative. And like this is an h, right? So it's sort of like h is in like the y spot, right? And so it's kind of like implicit. We talked about how the first derivative is always inside the second derivative when doing implicit. Okay? So you derive, fine. So negative 1/4 y prime or h prime or dh dt. And then that guy derives to 0, obviously. Okay, and then now I'm replacing dh dt with what I know it is. So that puts me to here, all right? And then it wants to, we need to evaluate that guy at 343. Okay, so like that's a 3, that's your t value. There's no t's in here. So you've got to use the 43 instead. Plug your 43 in, do some arithmetic, and you get 1. 1's greater than 0. Now your second derivative tells you about concavity. So if you have a positive concavity, that means you got concave up, like this guy right here. And so any tangent line that you draw is going to be below that curve. So you're going to get an underestimate. Part C. This guy now says instead of using this as your derivative for your internal temperature, you're supposed to use this as your derivative for the internal temperature. So dH dt is gone. It's now been replaced with dg dt. And it wants you to find g of t. Okay, so we got to integrate, but like right now, that's a g and that's a g. That's not good. So you got to get your g's with your dg's and your t's with your dt's. Now in this case, there are no t's, so I'm just going to let the negative sign sit next to the dt. So divide both sides by g minus 27 to the 2/3, multiply both sides by dt, puts me to here. Bring this guy upstairs to integrate it, put you to here. Okay, so now you got to solve for c. Well, you know that 0, 91 is a coordinate. So where I see g, I'm putting 91. Where I see t, I'm putting 0. And evaluate it, and you get 12 equals to c. So now this is just a rewrite with the c value replaced. Okay, and then just start whittling it away to get g by itself. So divide everybody by 3, puts me to here. Cube everybody, puts me to here. Add your 27. So that's g all by itself right there. Okay, so that's fine. And then you're supposed to use that to determine the internal temperature at time 3. So now just wherever you see t, you can put a 3. So if I put a 3 right there, that's obviously now -1, and -1 plus 4 is 3. So 3 cubed plus 27 is 54. All right.